Now, one thing I want to briefly talk about is the difference between polynomial time and exponential time. Also sometimes, associated with a problem which is NP hard. Yeah? So for instance, let's take a deck of cards which have numbers on them, right? So the numbers from 1 to 20, you throw them up in the air, whatever numbers you have, you throw them up in the air, they land on the floor, and all of the sides where the numbers are on are all covered. Okay, and so now what you want to do is you want to sort these from small to large. Okay, so how many steps do you need? And in fact, we can, obviously you can use smaller, fewer steps, but that would just be by coincidence. The largest number of steps that you would have for the first time is that you have to turn 20 cards around in order to find what the smallest number is. Okay, so you put the smallest number up. What's the next step? Well, in the next step, you have to go through these cards again, and you need at most 19 steps in order to find the second smallest card, and so on and so forth. And so, as you can see, the total number of steps is bounded, or will be actually, it's bounded by n plus n minus 1 plus n minus 2, which we know is Gauss' formula, which is n times n plus 1 divided by 2. So that gives you the number of steps that it takes for you in order to figure out how many times do you have that. And you see the numbers of steps that you have is n times n plus 1. So that is a polynomial. So in other words, this problem can be solved in polynomial time. Now, what kind of problems cannot be solved in polynomial time? Now, I'm not going to go into the math and the details of that, but you may have heard about the traveling salesman problem. So the idea there is that the traveling salesman wants to visit a certain number of cities, right? So there are n towns, and he has to find, and he wants to visit each town exactly once, and he has to figure out in which order he wants to do this. And that problem is actually one which requires you exponential time in order to solve, or it is an NP hard problem, right? Why is that? Well, because when you visit the first city, so you could visit the first city and then the second and then the third, or you can have the first and another, city A, B, C, A, C, B, and so on and so forth. And there's a lot of different variations, and when I say a lot, there's an exponentially large number of variations that you can look at and that you have to find the minimum over. So that is an NP hard problem. Okay? Now, for our hashing and our cryptography part, this matters because when you have a problem which can be solved in polynomial time, then a standard computer can solve this relatively quickly. When you have a problem that cannot be solved in polynomial time, but only in exponential time, then the computational power that you need in order, is essentially, if you make the problem just a little harder, becomes exponentially harder. So for that reason, an NP-hard problem is one which, if you have set up the encryption in such a way that somebody wants to crack it, needs to solve an NP-hard problem, you are relatively secure.